Hi, I'm Tom Nahumi from DELL EMC. In this demonstration video, I'm about to give you an overview of the new vSphere with Tanzu VM service feature and what benefits do we get from running it on PowerStore vVOLs. With the release of vCenter 7 U2A, VMware has introduced VM Service. VM Service runs on top of vSphere with Tanzu and allows developers to deploy virtual machines using kubectl declarative object configuration while simultaneously allowing the IT administrator to govern resource consumption and service availability. VM Service allows DevOps engineers to deploy and run virtual machines in a shared Kubernetes environment. Virtual machines are deployed using kubectl-like containers directly to the supervisor namespaces. As you can see, I have a vSphere 7 Update 2B environment. Under my Tanzu supervisor cluster, I created a namespace and two Tanzu guest clusters. Under the Storage Policies tab, I selected both PowerStore vVOL policy, which represents my PowerStore vVOL data store, and the Tanzu policy, which represents a VMFS data store. By navigating to PowerStore Manager and selecting the Storage Containers tab, we can find the default vVOL data store. Right now, there are no virtual machines running on it. You can see the vSphere HA file, which is used for data store heartbeating. By clicking on the vCenter Server Connection tab, we can see that our vCenter server is already registered, including the VASA element, and we are ready to provision vVOL-based virtual machines. In order to access the VMware Service tab, we navigate to the Workload Management tab and then click on the Service VM and select the VM box. Virtual machines are deployed in predefined sizes. All sizes that are available for Tanzu Kubernetes Guest Cluster virtual machines are also available in VM Service. If you want to define custom sizes, you can create your own VM classes. Virtual machines in vSphere with Tanzu namespaces are templates that have to be deployed from a content library. VMware provides supported images in their marketplace, so users can upload them directly to the vCenter content library. Now, let's connect to a supervisor cluster and create a new virtual machine using the new VM service. I'm logging in using my vSphere credentials and changing the context to the namespace I've just created. By running the kubectl getNodes command, we can verify that we are connected to the supervisor cluster and the ECXI hosts are listed as my worker nodes. As I've mentioned before, in vSphere with Tanzu, VMware SPBM policies represents Kubernetes storage classes which can be used to create persistent volumes using the VMware CSI driver Cloud Native Storage. To create virtual machines using the Kubernetes API, we use, of course, YAML files. As you can see, this is a custom resource definition developed by VMware. We need to provide the name of the VM and its namespace. The image name parameter is a supported CentOS image I downloaded from the VMware Marketplace and uploaded to my content library. Under class name, we specify the size of the VM, based on the predefined sizes in which virtual machines can be deployed. As for the storage class name, we specify the vVOL SPBM policy, which automatically creates virtual volumes for each virtual machine file. To manage virtual machines, it is required to know in which networking mode the supervisor cluster is running. VM Service supports both NSXT and distributed port groups. When using NSXT, VM operator will automatically create the required network segments and attach virtual machine interfaces. In that case, you just need to set network type to NSXT. We create the VM by running the kubectl apply command and specify the VM YAML file. Listing the Kubernetes events provides us with more details about the deployment process. In order to connect to the virtual machine using SSH, we have to create virtual machine service object. This will create a load balancer that is externally available using an IP address from the supervisor cluster ingress pool. We can retrieve the external IP by running the kubectl get service command. Upon login, the system asks you to change the password and closes the connection. From then, you can log in again without a password, just using your SSH key. Now that I'm connected to the virtual machine, I'm installing FIO tool to generate some storage workload and show you the tight integration we have between VMware vVOLs and PowerStore. If we navigate to PowerStore Manager and click on the Virtual Machines tab, we can see that PowerStore automatically detected the newly created virtual machine that we've just created using the new Tanzu VM service feature. We can see useful information about the virtual machine, such as the managing ESXi host, the guest OS operating system, the capacity, and the protection policy. And it doesn't stop here. PowerStore collects and displays both history and live performance metrics about the virtual machine, allowing the storage administrator to get full visibility of the virtual machines running on the PowerStore storage array. In addition to the compute performance, we provide storage performance metrics showing the total IOPS, bandwidth, latency, and IO size of the specific virtual machine. And if it's not enough, because each VMDK file is a virtual volume at the array level, we have more granular view of the performance of each and every disk of that VM. Now, let's generate some storage workload using the FIO tool that I installed on that virtual machine. By going to the main performance tab, we can see the total performance at the array level. If we navigate to the specific VM and select one of its disks, we can get live performance metrics of that disk, allowing the storage administrator to get full visibility of the workloads running in his data center and virtual machines, no matter if they are regular virtual machines managed by the new VM service feature, supervisor Kubernetes pods, and Tanzu guest clusters, all from the same single pane of glass. I really hope you find this demo useful, and thank you very much for watching.